My talk is called A History of M, how the Messier catalog came to be. Just to let you know, I have prepared myself with various provisions here. I have my hand sanitizer. I have sustenance and other important equipment. So welcome everybody. I wanted to talk a little bit about the history of the Messier catalog, which as amateur astronomers most of you have probably heard of. I'm willing to bet that a good many of you have been out under the stars on a night like this, and you've heard things like M13, M57, M51, things like that bandied about. And it gives you a kind of impression that these we know are from are objects from the Messier catalog. It gives you kind of an impression that the Messier catalog sort of was formed in whole cloth. It was something that has been around for a very, very long time. But in fact, it's actually an evolving, it has evolved over a really long period of time. It was something that was cobbled together in fits and starts as a very long, probably 2-century long project that has only very, very recently come into the form that we know of today, of having 110 objects that amateur astronomers know and love. I'd like to talk a little bit also about why the Messier catalog has become such a staple of imaging and observing by amateur astronomers and by professional astronomers as well. It features some of the most interesting objects in the night sky. Why is that? Why did the Messier catalog, of all things, come to be the cornerstone? So I want you guys to take yourself back into the 18th century. It is August 28th, 1758, and you are sitting atop a tower right here in the Hotel Cluny. By all accounts, it was a warm, lovely night, and you are a young Charles Messier who is attempting to hunt down Comet Halley. So that is the start of the Messier catalog. That is how the Messier catalog opened up. But let's back up a little bit and talk a little bit about the Messier catalog itself. This is a map. I just downloaded it off of Wikipedia that contains all of the Messier objects. And I'd like to mention why we are actually talking about the Messier catalog in March. This is a map of the distribution of the objects in the Messier catalog, and you'll notice that all these little colorful dots here, if your screen resolution is decent enough, these show the locations of all 110 of the current objects. This green line right here is the ecliptic. The ecliptic is the path that the sun appears to trace through the sky over the season. So as the Earth goes around the sun, we look back at the sun, and if we could see the stars behind it, this would be where the sun would appear in the sky at various moments. This upcoming weekend, if you were to take note of where the sun was, I've put a little dot over here in the side. That little dot right there represents the position of the sun on March 21st, which actually turns out to be the ideal time to do a Messier Marathon this year. A Messier Marathon is the observing of all of the Messier objects in one single night. Well, why can you do that? And why does this particular event typically happen in March? Well, take a look at the distribution here. The sun happens to sit, and it's hard because this particular chart was actually set up in such a way as to show you where all of the objects are, and ignore the gap. But there is actually an empty space over on this side on the left and on this side on the right, where if the sun is sitting, that we can capture some of the all of the objects without actually the sun actually blocking them out. The sun sits very, very nicely in this gap in a time frame that spans from about maybe the second week to about the the end of March, the fourth week of March. And so that's why we're actually talking about this in the month of March. So, Charles Messier, let's talk a little bit about him. He was born on June 26th in the year 1730, so he would have been on that fateful August night just 28 years old. He lived a good long life for his time. I mean, he lived all the way up till 1817. Some of the latter years of his life, he wasn't able to see very well, so his astronomy business went downhill in the 19th century. But for most of the latter half of the 17th century, or the 18th century, he was a very active astronomer. He was born in a town, and my friend Wilkie Cirker, who is probably listening to this right now, will cringe at my French pronunciation, but he was born in the Alsace region of France in a place called Bedonville, is as best as I can do. And this is a moderately sized town. He took an interest in astronomy very early on. He was from a fairly well-to-do family, one of the wealthier families. There's some myth that he actually was a self-made man. That is not the case. He actually was fairly well off and connected. But he actually became interested in astronomy very early on, and his mother was instrumental in introducing him to astronomy. One thing that really helped out with his career is that he had exceptionally good handwriting. And so in 1751, when he found himself going to Paris to seek out his fortune, he ended up at the Paris Observatory asking for a job. And the thing that got him the job was, well, first of all, he was fairly well off, and if you were well off, you were assumed to be a reasonably upstanding person in those days. Second of all, he had an interest in astronomy at the time. And third of all, he had exceptionally good handwriting. And that was extremely important in the days, as you will see in a moment, because he actually was set to the task of making maps. He also was given the task of observing various things, and one of the earliest things that he observed was a transit of Mercury in the year 1753. As you can see, this is not a picture of the 1753 transit because the 1753 transit went down here somewhere. This photograph is not of that time. Okay. He was also exceptionally interested in comets. And this is owing to the fact that probably early on in his life, he experienced and wrote about the great six-tailed comet of 1744. This was an extraordinary comet that was an awful lot like Comet McNaught that appeared in the early 2000-aughts, which was extremely vast in the southern sky. Here in the northern sky, we didn't quite get as good of a view. But it had 6 tails, or so they said, and this typically results from the comet spinning in space. And as it spins in space, kind of like a garden hose, it sprays out these tails, which form multiple individual streamers, and eventually you end up with a six-tailed comet. Usually comets only have 2 tails, but if you get a certain location of the outgassing on the comet, you'll get these interesting features. This was an exceptionally bright comet, and for the rest of his life, he was extremely interested in comets. So he also set himself to the task of looking for comets. Well, why did people look for comets in those days? First of all, if you were someone that was interested in astronomy, you could kind of make a name for yourself, almost literally, by discovering a comet. Even in those days, comets were one of the few things that if you discovered it, you could get your name on. You know, people would know the comet to be that comet discovered by so-and-so. So if Charles Messier discovered a comet, it would be Messier's comet, and people would know his name, and that would hopefully land him a position in the French Royal Academy of Sciences, which was just kind of getting its start. Second of all, comets were also an interesting scientific thing in their own right. People didn't quite understand them. It was only just recently, within the last century or so, that people came to realize, a century or so in 1744, or in the middle of the 18th century, that people had begun to realize that comets were most certainly objects outside of Earth's atmosphere. They were not of our Earth. They were individual things orbiting the sun. And so people were interested in learning about comets as a scientific endeavor in its own right. And Charles Messier was actually very, very good at hunting down comets in the night sky with the telescopes he had available to him. And in fact, he got a name for himself, and King Louis XV called him the ferret of comets. He was the guy who ferreted out the comets, and that was his nickname for quite a long time. Over the course of his life, he ended up observing dozens of comets and actually discovering independently on his own at least 13 of them, one of which was a rather spectacular comet, which I'll show you a picture of, a rendering of in a little bit. But one of the main quarry of comet hunters in those days was to find and be the first person to spot the comet that Edmund Halley predicted would return sometime in 1758. Edmund Halley had actually looked back through the history of comet observations, and until that time, until before the age of Charles Messier, only about 50 comets had ever been historically observed and written down. It was, there weren't a lot of comets, and with the age of the telescope, people started really hunting them down. So this was actually a fairly new endeavor. And Comet Halley predicted that a certain comet had a certain orbit and would return sometime in the year 1758. Charles Messier found himself under the tutelage of the director of the astronomer of the Royal Navy, who had set up shop, and I will zoom back here because I didn't put a slide in, set up shop on this building right here, which still exists to this day in France. It is the Hotel de Cluny in Paris, and it's now a museum which you can actually go visit and see. And he set up on top of this tower right here a number of telescopes which Charles Messier used over the course of his career. His boss was a guy named de la Cille, and de la Cille was very happy to have Charles Messier working for him. So happy that he had him, hunt down comets, but to help him learn the ropes, he also set him to the task of making maps. And the very first map that he was set to make was a large map of China. I could not find a copy of the Messier map of China. Well, this map was several feet in size, and there weren't any tables large enough for him to actually sit down and make this map. So de la Sille put him in a cold, dank cellar with a very large table on it, the only place that they could find. And someone said, "Well, aren't you worried that Charles Messier is going to freeze down there in that cold, dank cellar?" And de la Sille said, "No, this is getting him used to taking long nights under the stars." He said that if you're going to be an astronomer, you're going to have to be out in the cold and the wet. And so Charles Messier got his chops in the cold, wet dungeon of the Hotel de Cluny, making maps before he actually started doing his official duties. So in August of 1758, Charles Messier began his investigations. He set up shop on the top of the Hotel de Cluny and started searching for Comet Halley. Now, he had a map given to him by de la Sille, who had made his own calculations of where Comet Halley should be. Well, it turns out that that map wasn't a very accurate map. Others had made other maps and predicted much more accurately where the comet would be. And in his searches, Charles Messier actually ended up running into something other than Comet Halley. First of all, he ran into a different comet, and this was a comet that had been discovered by someone else, much to his chagrin. It was discovered by a gentleman by the name of de la Nucht a few months earlier. He wasn't aware of this at the time, so he thought he had discovered it, but a few days before he had actually made this particular observation, he learned that de la Nucht had actually been discovered much earlier, so he didn't get credit for it. But in the course of his investigation, he writes, "I discovered above the southern horn and a little distant from the star Zeta in the constellation of Taurus," by the way, "a whitish light elongated in the form of the light of a candle." So he found a little fuzzy object in the night sky. And very importantly, and this is one of the things that's key to the career of Charles Messier, and one of the reasons why we remember him so well, is he actually wrote down very precisely where this particular object was. So this object, he used this particular map. Now, this internet copy of the map was a little low resolution, so I inverted it here. Or it wasn't didn't have a lot of contrast. So this here is the path of the comet de la Nuxt, which he was observing on the night of August 28. And right here, this is actually the constellation of Taurus. Here's the Hyades. Here's Auriga is over here. And if we zoom in, he made a little note right here that said, "A new nebula discovered on the 28th of August, 1758. He made a little blob there. He said, "This is something worth noting." So he actually wrote it down on the map. And if you want to know a little, and this is another sample here of Charles Messier's handwriting, he actually made this particular map. If you look up here, he signs it, prepared at the Hotel de Cluny, at the Royal Observatory of the Navy. So, and this was one of his maps. So this object, probably many of you know, was in fact we now refer to as M1. Charles Messier wrote down the position, noted that it wasn't in fact moving like a comet, and so he took note of it. Now, this wasn't the first one of these fuzzy objects observed in the night sky. it was, other people had, in fact, encountered fuzzy things in the night sky as well. In fact, Edmund Halley himself had collected a list of fuzzy objects that he had encountered every once in a while. His list had a grand sum total of 6 objects, which is one of the reasons why Charles Messier's catalog is fairly well known. There were other catalogs as well. None of them had very many objects in them. They were sort of these happenstance collections of objects that people happened to run into. But this little guy right here, Charles Messier took note of and wrote it down for posterity. So the next season, starting in January, he actually discovered his first comet that had his name. It was Comet 1759 Messier. Now this isn't 1759 Messier. This is Comet Mach-Holtz, a picture that I took a little earlier, but I made it look like that. So, and he also independently found Comet Halley. Now, unfortunately, though he did not realize this, he was not the first person to find Comet Halley. He was misled, unfortunately, by de la Sille, his boss, by his catalog, and this probably prevented him from actually finding the comet. It was found instead by Johann Georg Pallich, a German, obviously, astronomer, and news got to him a little late, and so Messier did not get credit and the glory that he would have gotten had he been the first person to discover Comet Halley. So the Royal French, the Royal Academy of Sciences in France did not offer him up an invitation that he so desperately wanted. So yes, I agree, Tom, Paris would not be the best for comet searching today because it is a quite bright city. Okay, so the next season he was out observing, and he writes the following. In September 11, 1760, I discovered in the head of Aquarius a beautiful nebula, and this is very important, which doesn't contain any star. We will get to that in a little bit. It's in the constellation of Aquarius, and you'll note down here that he found it while he was using the chart of Comet Halley, this time the correct chart of Comet Halley, which he continued to observe over the following months. I like this right here. It is he says he observes with a Gregorian telescope, I will get to that in a bit, of 30 poses. Poses means thumbs. Thumb is a unit of measurement which is roughly the equivalent of 1 inch. They called thumbs poses, or inches poses in those days. Well, that object we've come to know as M2. And he makes a very interesting comment down here. He said, I at first took this nebula for a comet. So it turns out that he's mistaking these objects for comets, and this kind of gets his attention a little bit. So here's a picture of M2. It's kind of my facsimile of maybe kind of how he saw M2. I had a very difficult time getting this picture not to have stars in it, but he obviously did not see any stars. In 1763, the pretty much highlight of his career was the discovery of a comet that was actually, at the time of its discovery, a naked eye comet. It was just barely able to be seen with the naked eye. It was the Great Comet of 1763. This was a very large comet with a very large tail, which was much noted and admired at that time. And this is a contemporary rendering of that particular comet. It probably had a tail 40 or 50 degrees long at its maximum. So he kept searching for comets, and in 1764 he ran into another object, which we now know as M3, and this became the birth of his catalog. He realized that he was starting to run into a lot of these objects which kind of looked like comets, but were of course not comets because they did not move. And he decided that he would, in addition to his comet hunting, start to try to hunt down these objects in and of themselves. He decided that maybe a good thing for him to do was to actually make a concerted effort to look for objects. M3 was the one that sort of finally clinched the deal here. So over time, he started making a concerted effort to both look for comets and objects, and very often he would find fuzzy objects in the course of his studies for comets. An interesting thing to note, if you are a person that likes star charts, if you take a look at the positions of some of the objects in the Messier catalog, as we know it today, you'll often see that objects that are sequential in number, that are very close together in number, like 16, 17, 18, are often very, very close together. And the reason why is because he was looking in that area of the sky at the time and just so happened to find three objects at the same time. So 16, 17, and 18 were all found on the night of June 3rd, 1764, a very productive night for Charles Messier. Let's go to the next. So here is another map of a comet going through the Serpent, the Comet of Serpents. And here we have another one of Charles Messier's maps. You can see how wonderful his handwriting is. I'd be curious to see if anybody could guess in the comments what part of the sky this is. I'm going to see if there's any comments. I bet there's a delay, so I'm not actually going to see be able to see the comments for quite some time. And if it's too long, I will wait. Sorry about the delay. Okay, now, this is from much later in his career. This says right here, 11 nebula observed in 1781. 11 nebula observed in 1781. This is the heart of the Virgo cluster, which he observed much, much later in his observing career. So let's go back here. Also, you'll notice that M36, M37, and M38 were all observed at roughly the same time. 36 and 37 were discovered on September 2nd of 1764. He first wrote them down, and on September 25th he went back to the same region and observed what came to be known as Messier 38. So these were all discovered sequentially. So if you explore the map, you'll find that Charles Messier's objects are often clustered together. There's a bunch that are observed roughly together. You can tell kind of what season he discovered these in. These were probably, these were discovered obviously in the fall. There's a M35 was also discovered in the fall as well. So that's because that's what was up at the time. His catalog numbers are not like some of the catalog numbers of more modern catalogs. In modern catalogs, for example, the more modern catalog of the NGC catalog, those are all sequentially numbered around the sky. They start at 0 hours of right ascension. That's the longitude of the sky, and they progress to 1 hour, 2 hour, 3 hour, all the way around the sky, and they are numbered in sequence from 0 to 7,844, I think, objects. I don't remember precisely. Charles Messier's are just willy-nilly according to where he observed them. However, he was making a systematic attempt to observe these objects and take note of their position. That was a very important category. So over time, he decided, you know what, I'm collecting these objects. I think I am going to attempt to publish this catalog. And in 1774, he published a list of what came to be the first 45 objects of the Messier catalog, all the way from M1, which is the so-called Crab Nebula, up to M45, which is the Pleiades. Now, if you're an observer of the night sky, you will recognize that I skipped one of my slides here, sorry about that. You will recognize that a few of these objects are pretty well known. I mean, if we start off with M42, you can see it with the naked eye. And in fact, M42 had been discovered telescopically a long time before Charles Messier came around. M43 was, of course, a nebula that was right next to M42. M44 is the Beehive cluster, which is in Cancer. That can be seen with the naked eye. It's a little fuzzy patch. And a really easy object to see, M45, the Pleiades. I mean, who could mistake that? That had been known since ancient times. There was even mythology surrounding it. So I'll go back here. Charles Messier actually kind of padded out his list at the end of his observing, padded out his list. Now, he wasn't taking credit for these observations. I'll show you a few pictures here in a second, which indicate that he was definitely not one to steal credit if he didn't actually discover the object. So these objects were put into his list simply for the sake of publication, to actually make his list an attractive list for people who were looking for objects in the night sky. No one would confuse these particular objects with a comet because they were well known at the time, but it also made for a very nice publication. Let me give you a picture here of the very first edition of this particular publication, and for those of you who don't speak French or know that this little guy is actually an S, it says a nebula without stars in the Wolf, and it was near the 14th star in the constellation according to Flamsteed. This was the Flamsteed 14. Would anyone like to guess which object was in the constellation of the Wolf near the 14th star of Flamsteed? Okay, and I'm hoping that the delay is not long enough. Well, if you guessed it in your head, I will of course reveal, as I had done earlier, that the answer is in fact M27, the Dumbbell Nebula. Right here is 14 Vulpecula. Vulpecula basically means the wolf, and so right next to 14 Vulpecula is M27. So he described it based on where it was located in the sky next to a star. He gave the approximate right ascension and declination, the longitude and latitude of the sky, but he also verbally described it when he was taking notes, and so people could easily look this up and find out where it was. Did anybody guess that? Oh yes, Jason got it. Nice job, Jason. Okay, I won't do this anymore because I realize there's about a 15-second delay in the stream, so I will hold off on any more quizzes like that. So let's go on. So here's a picture that he drew later on in his career. If you can see, if you can zoom in just a little bit, this is actually a picture of M31. It's not a very good picture, but it shows you kind of what Charles Messier would have seen. He notes right here that this is a grand nebula discovered by Simon Marius in the year 1613. Now, he was giving credit to Simon Marius, where probably Simon Marius shouldn't have gotten credit, simply because this object is visible to the naked eye, and astronomers back to antiquity, dating at least as far back as the time when Arab astronomers were observing the night sky, recognized this little object in the sky even before the age of the telescope. But Simon Marius was actually the first person to point a telescope at it and confirm that it was a big fuzzy thing in the sky. And so Charles Messier, on his chart here, which he published, gave a credit to Simon Marius here. And down here is a rather interesting little object. This is a picture up here of Simon Marius, by the way. I have no idea what he's holding, but I don't want to ask. Another astronomer by the name of Le Gentil discovered a little fuzzy patch next to the object, next to the Andromeda Galaxy here, and that turned out to be M32. And this picture was drawn later on in his career in 1773, and he takes credit for it. Messier, in his course of observing this M31, which we come to know as M31, he discovered this, which we come to know as Messier 110. But he did not put it in his catalog. He just assumed that it was a part of. He just assumed that it was a part of his this larger object, and so collected it into the same grouping. Right here, this is a picture of Le Gentil. He obviously, of a man of his age, wore a wig made of human hair. If you were a person of means in those days, you didn't go around with your own hair sticking out. You made yourself a wig. And Charles Messier was said to have observed with his own wig on at times. He was not. He was apparently proud enough about his appearance to observe in the fashion of the day. So here's a little picture I took of M31. Another picture he drew of the Orion Nebula here, and you can see that his telescope was good enough to actually spot the individual stars at the heart of the Orion Nebula, but he didn't see it exceptionally well. This picture was drawn in 1774. So he continued to observe over time, and eventually he published a supplement to his catalog in, and actually that is not correct. Oh yes, it is. I'm sorry. He published a supplement to his list in 1780. He had observed nebula all the way up through what we now know as M70 today. Now, I put a few question marks on these because there are a few that in this particular publication and throughout his career, these were objects that were somewhat in question. He made a few mistakes from time to time, and we'll get to that in just a second here. So let's talk a little bit about those mistakes. So Charles Messier observed what came to be known as Messier 48, and he reported it at a location of 8 hours, in the rather precise location of 8 hours, 2 minutes, and 24 seconds of right ascension, and a declination of -1 degree, so it was just below the celestial equator, 16 minutes and 42 seconds. Now that's an exceptionally precise measurement of where this object is, especially given the fact that this is a fairly large object. I mean, larger than the moon in size. And in fact, you can, on a really good night, you can in fact see this object with the naked eye. Now, this object was a little bit off of where he. This 13 minutes is almost negligible given the size of the object, but this here is almost 5 degrees off. That's a pretty good size. I mean, that's about the width of your fist held up at arm's length in the sky. And for a long time, people sought out this particular object, M48, and they couldn't find it. Well, let me show you what he was doing. Actually, my charts are not. I will show you. So when Charles Messier was observing, he often used charts to plot the location of the objects. Now you'll look right here. I don't know if you can see this, but I'll show you if you could follow my mouse here. We've got 330, 335, 340, 345. That is degrees around the sky. He's not actually charting the sky in right ascension. He's charting it in the number of degrees around the sky. 360 degrees in the circle, all the way around the sky, 360 degrees. And then he takes the degrees of declination, 0, 5, 10, right here. And if you look very closely at what happened here, it turns out that he reduced this is his published location. He actually had to make a conversion of the degrees and minutes of this particular object to from this map to his notebook, and in so doing, he occasionally made a mistake. In the first case, he actually probably didn't make this calculation fairly accurately, fairly precisely. So this is a little bit off. And then he also probably looked at his chart and accidentally traced the wrong line to the edge of the chart. So, I mean, many of you may have done this where you're looking for an object and you're trying to find something that's 70 degrees of declination, and you follow your little star chart around, and oops, I'm on line number 65 instead. Well, he accidentally picked the wrong line when he was doing this, and people found this out many years later when they investigated his notes of where things were in the sky, and they were able to correctly, or so we think, identify this particular object that he had discovered. There's a large, almost naked eye star cluster at that region, at this particular location. So it's pretty certain that, and this is fairly close to that, it's pretty certain that this is the thing that Charles Messier was referring to. So the catalog actually started off, it wasn't perfect. It had a number of mistakes built into it. M47 was also similarly incorrectly reduced. He made almost exactly the same mistake with M47. So along about this time, starting in probably the late 1760s, early 1770s, we don't quite know when, he became associated with another astronomer named by the name of Pierre Messier. Pierre Messier was at this time beneath Charles Messier, who had taken over de la Sille's job at the Royal Navy's observatory, the observatory of the Royal French Navy. And so Messier was in fact working under Charles Messier. And Messier was a devoted observer as well. And they teamed up in hunting down objects in the night sky. And for instance, if you will take a look at this map right here, this was a map of, yes, Marshall, I will get to his telescopes in just a bit. All of these objects up here were discovered by Messier, and a number, M61 also. Let me show you a list here. I got a list of, okay. Messier himself, in fact, discovered 26 individual objects, 63, 72, 74, 76, and then these guys here, 85, 94, 95. These are 85 and 94 are part of the Virgo cluster. 98, 99, 100 are all kind of outliers of the Virgo cluster as well. He was a very prolific observer. Charles Messier, in fact, discovered himself 40 objects, and Messier discovered 26, if you count Messier 102 as well. So he was a pretty prolific observer. Now, there's a problem. Messier was not quite as diligent in his notation of where things were as Charles Messier. I don't know if this was owing to his handwriting, but I'll talk a little bit about the curious case of M102 here in a little bit, and make a suggestion that perhaps handwriting came into play in one of the mistakes in the Messier catalog. But a good deal of the Virgo cluster was discovered by Pierre Messier. So let's go here. So I want to talk a little bit about, while I'm talking, you guys can post what you think this particular object is. I want to talk a little bit about why we observe the Messier catalog today. And this sentence right here from Charles Messier's notebooks is a good indication of why the Messier catalog is such a well-known catalog amongst amateur astronomers. He says that this particular object is a nebula without a star. That's a very important thing to note. Discovered in the belt of Hercules. It is round and brilliant. The center is more brilliant. Joe is correct. It is M13, in fact. M13, and as you will see from this picture that Joe himself, in fact, took, because I stole it from his website. Thank you, Joe. The M13 has a large number of stars. Well, why didn't Charles Messier see that this, in fact, had a lot of stars? Anyone with a 3-inch refractor, modern telescope that you could probably buy for a couple $100 here today with a very modest power and extremely small aperture, could note that this particular object, in fact, has stars. So let's talk a little bit about why that is. So this is a picture of what telescopes in really good telescopes look like at the beginning and the middle of the 18th century. This is a picture, a rendering of the Paris Observatory, and I want to direct your attention to this guy right here. This very, very long telescope right here is sort of par for the course in those days. Well, why is that? Well, there is a problem with making telescopes out of glass, and that is something called chromatic aberration. If you actually pass light through a glass or something made of quartz, the light will in fact be dispersed into the constituent colors of the rainbow. Here's of course a picture of the moon, and this is a picture of the moon taken through some optics with pretty bad chromatic aberration. One thing that you could, in those days, telescopes were primarily refractors in those days, and so people were actually looking through telescopes made of glass lenses, and they had not yet developed. Early on in the 18th century, they had not yet developed a good technique for getting rid of this. There was in the middle of the 18th century, the apochromatic refractor was developed, which was a technique of using two different lenses to cancel the chromatic aberration out. However, this was not commonly used at the time, and it was actually rather difficult to manufacture. So for the most part, your telescopes had very, very bad chromatic aberration. And so what people did was, in order to get rid of that, it turns out that if the focal length of the telescope is much, much longer, if the light is actually not being bent as much, the chromatic aberration is minimized. But in so doing, you have to actually make a very, very long telescope. So let me show you a picture of one particular telescope from the late 17th century, early 18th century. This is a telescope that had a length of 150 feet. This was a rather unwieldy thing to do. So this was pretty much the standard telescope of observatories in perhaps the late 17th, early 18th century. Well, along came Isaac Newton, and he developed a technique for actually making lenses, or actually mirrors out of glass, and developed a telescope. And people started observing with telescopes made of mirrors. Well, let me show you. This is a contemporary telescope, a reproduction of a telescope that Charles Messier would have used in his time. This is a very, very narrow refractor, about a 2-inch refractor with a very long focal length that was probably built in maybe 1750 or so. This would have been something that Charles Messier might have had around. So after Isaac Newton said, hey, you can do this with mirrors, people started building telescopes with mirrors. Now, that does solve the problem to a certain extent of chromatic aberration. You're still not getting rid of the chromatic aberration from laser pointer. I just was reading Mark Peters' thing. Sorry about that. You're not getting rid of the chromatic aberration from the eyepieces themselves. They introduce a little bit of chromatic aberration. But you are getting rid of the chromatic aberration from the mirror, from the light gathering mirror. This is a particular style of telescope that was common in those days, called a Gregorian telescope. And it's sort of like what people would see today as a Cassegrain telescope. It's a telescope with a primary mirror that has a hole in the middle, and the telescope, the light comes down in here, hits the mirror, goes back up, hits another little mirror, and then comes out the eyepiece. Now, that might solve the problem of chromatic aberration, but there are other problems with this particular style of telescope. So here's another style of Gregorian telescope. It was they would dispense with the little secondary mirror, and they would stick the little eyepiece out to the side, and they would make do with coma by having the eyepiece look down into your face would actually face the mirror. And this was another style of telescope in the time. This was one of the styles that Charles Messier actually used. There's another, this is a Gregorian telescope. You'll notice that for reflectors, their focal length is actually quite long, and their aperture seemed to be, they were usually about 3.5. The biggest one that Charles Messier had access to was 7.5 inches long, but it had a very, very long focal length, and it was rather unwieldy to use. So he tended to use like a little 3.5 inch telescope. This is a reproduction of a telescope that the Cook expedition to Tahiti used when they observed the transit of Venus across the sun from Tahiti. And that would have been a really great trip. And so it's contemporary with what Charles Messier would have been familiar with. Here's another one later on. You'll notice that the focal length is always quite long. Now, if you can imagine that the light comes down here, hits the mirror, hits another mirror, hits another mirror. So these are something like f20 or something like that. Very, very long focal length. So I'm not seeing any comments. Is everybody getting the, could I get an emoji to see if everybody's actually seeing me, and I will, or some sort of comment to let me know that everybody is still there? Okay. I'm going to wait for now. Time for a glass of water here. Pretty long delay there. See how many people are watching. We have 23 on the live stream. Just want to make sure that the sound is good. Yep, got it. Thank you. Thank you, Joanne and Jason. Yes, awesome. Thank you. Okay, so I will continue. Sorry about the delay there. So, obviously, these solve a lot of the problems of chromatic aberration. You know, that makes the view through a chromatic aberration makes the view through a telescope not so great. But there are other problems, and the number one issue was the state of the art of mirror making in those days. And this is actually a mirror made by William Herschel. It's about a 6-inch telescope mirror, and you'll notice that it's not particularly reflective. It's actually made of a substance known as speculum, which is a mixture of various other metals. One of the ingredients of speculum metal is actually arsenic, and there's an interesting story if you go to the Bath home of William Herschel. You'll learn that William Herschel actually almost poisoned himself a couple of times making speculum metal for his mirrors. Number one issue with the mirrors of the day. But the other issue is that it's not particularly reflective. At its best, it's probably about 60% reflective. But it tarnishes very, very quickly. And consider with a Gregorian telescope, you have, just like a Cassegrain, you're reflecting the light off of 2. So if you get half the light, you know, because assuming that your mirror is tarnished a little bit, you're getting half the light, and then you're getting half of that light from the reflection. You're only getting 1/4 of the light that you would get out of a really good, 94 enhanced coating optics amateur telescope of today. 94% reflectivity is par for the course in our day. So the telescope mirrors look like this. This is actually a picture from the British Museum. This is a telescope mirror that was made by Isaac Newton himself. It's kind of interesting. And you'll notice that the speculum metal is not particularly great. I mean, obviously these things have tarnished over the years. But even in those days, the metal was not that great. I'll show you a picture here of, this is an actual speculum mirror. This one was a facsimile in the British Science Museum. I took this when my wife and I visited London and back in the early 2000s. This is something that they noted down at the bottom that they in fact polished to show us how it looked, and you can see that this is a speculum. This is about as good as speculum gets. Now this is a 40-inch mirror that William Herschel made. Charles Messier did not have access to telescopes that were nearly this big. As I was saying, his telescopes were 3.5, 7.5 inches across with very, very long focal lengths. So, in general, if through his best telescope, I'm sorry, Greg, I do tend to talk a little fast, yes. I apologize. Through his best telescope, Charles Messier probably would have seen M13, which is a glorious ball of stars in even a 4-inch amateur telescope from today, as just a little blob like this. So this is my simulation of what he would see in the best of times. And his field of view was very, very narrow. His minimum magnification was often on the order of 100 power. He would often say, I'm observing with my telescope of 104 magnification. I ran into this particular object. So basically he's looking down a soda straw. So it was extremely difficult for him to find things. All this adds up to the fact that his telescopes, by modern standards, were pretty lousy. And as such, his telescopes gave us the ability, his telescopes only afforded him a view of the best and brightest objects in the sky. And that is why I think one of the reasons why Charles Messier's catalog is so well known today is because he made a concerted effort to observe objects in the night sky, and he did it with really bad telescopes that could only see the best and brightest objects in the night sky. Here's another map. If you guys look closely, you can actually see that this is a bear, and I will get your bearings here a little bit. If you can follow my mouse, this right here, these 4 stars. Some of these old star charts are kind of hard to see the patterns of the stars because we're used to a lot more gradient in the star sizes in our star charts. But this right here is the head of the head of the Big Dipper, the tail of Ursa Major, the hindquarters of Ursa Major. And there was a comet passing through this region in 1781, and Charles Messier actually observed it, and he ran into these little guys up here. Nebulas observed in 1781. If we zoom in a little bit, you can see those nebulas in 1781. I'm sure a lot of you will automatically know what this is. This is, the larger one here is M81, and the other one is M82. M81 had actually been observed slightly before Charles Messier, and he gave him credit by a guy named Bode, an astronomer named Bode. And M82 was in fact a discovery of Charles Messier. So, Charles Messier continued to observe, and Messier continued to observe as well. And Messier actually collected all of the observations that or a good portion of the observations that they had made, into a third and, for his lifetime, final publication in a magazine, and I will mispronounce this, I'm sure, called Connaissance des Temps. It had 103 entries in it. Now, you will notice that there are question marks on several of these. A number of them are objects that were described, but at the time they were misidentified, or their positions were misidentified. So here's a picture of the front page. He said a catalog of nebulas amongst the stars, and he gives a little introduction here. Here's the opening here, and you'll see that he actually takes note of when he observed them. It wasn't always the discovery date that he noted. It was when he nailed it down. He was always very careful to take note of the date that he in fact decided that, yeah, this is exactly where it was. He took note of his estimation of the location of it in the sky, the right ascension. This is in degrees, which were common on his maps, and this is in a right ascension right here. And right here is the declination. So he actually takes note of this in 2 degrees. Now, occasionally, what ended up happening is that he would have one object listed in degrees, and then this would be the wrong translation. A couple of the mistakes in his catalog were from the reduction of his numbers. He was very careful to take note of where things were, but his math was sometimes off. Or, as we saw before, he sometimes picked the wrong line on his star chart. So here's number 1, diffuse nebula in the head of Taurus, and that kind of thing. So if you guys read French, you can actually find a copy of this online. By the way, most of my material here came from either Wikipedia, which was a wonderful help of nailing down a lot of the history of some of these objects, and for a wonderful website, which hasn't changed in 20 years, unfortunately, but a website that's still up called Students for the Exploration and Development of Space, SEDS. So if you Google SEDS Messier catalog, you will find more information that you can possibly imagine about the Messier catalog. And at the end, he did a very interesting thing. Throughout his career, Charles Messier not only sought out new objects and accidentally bumped into other objects and padded out his catalog with still further objects that he knew about, but he made an effort to confirm the observations of other observers who were his contemporaries and who came before him. So on the very last page of his final published catalog here, and actually in the previous version as well, he made a list of all the objects that he attempted to hunt down and failed to do so. So for example, this object found by Hevelius, he's saying, hey, maybe these things are not really up there. I tried really, really hard to find them. So he was a pretty good scientist. He actually did a really good job at attempting to confirm the observations of other observers, and he was not proud enough to give them credit when credit was due. So the Messier catalog was pretty much in that form for a very, very long period of time. It was published in France, and not a lot of people paid much attention to it after that because it was superseded by the catalogs that came afterward. As I was talking, a few years after 1781, William Herschel started observing in earnest, and he was using much better telescopes and ended up observing something like 2,000 objects. His sister Carolyn actually contributed to that as well. And that particular catalog evolved eventually into what became the NGC catalog, the New General Catalog. Thank you, Joanne. The New General Catalog. And that catalog was published in the late 19th century. I believe it was 1888 by Dreyer, and it ended up having over 7,800 objects in it. At that time. So those catalogs became kind of the de facto go-to catalog. But in 1921, people were starting to be interested in the history of astronomy. They were going back and actually figuring out what was interesting. And a astronomer by the name of Camille, I misspelled his name, as Flammarion, and I probably mispronounced his name, took a look at Charles Messier's notes and decided to republish the catalog. He thought, hey, this is a pretty good list, and said, hey, this is really interesting. And he added one extra object that had been observed by Messier and Messiaen, M104, the Sombrero Galaxy, and the catalog grew a little bit. Of course, we still had these problem objects, so over time those got corrected. In 1953, someone you guys may have heard of by the name of Owen Gingerich, who in fact did a talk at Perkins Observatory a few years ago, and a well-known author of astronomical topics, published in Sky and Telescope, not this exact edition, unfortunately I wasn't able to find that cover, but published in a 1953 edition. This is a 1953 edition, November of 1953, of Sky and Telescope, the Messier catalog. And he added to it an additional set of objects, 105, 106, 107, 108, and 109. These were objects that were noted in the personal copy of Charles Messier's catalog. He published it, kept a copy for himself, and as he was still observing over the course of his career, took notes of a few other objects in his own handwriting, which was very neat, of course, and added. And Owen Gingerich, who loved to hunt down the marginalia of various famous astronomical books. One of the book that he was actually talking about when he did his talk at Perkins Observatory was the Nicholas Copernicus's De Revolutionibus, the original publication. And at the time, Nicholas Copernicus's book was called The Book Nobody Read. And Owen Gingerich actually sought out as many copies of the Nicholas Copernicus copy of De Revolutionibus, and ended up discovering that a lot of people had taken notes in the margins and indicated that they had in fact not only observed, but they had absorbed what Nicholas Copernicus was saying. So not only was it read, but it was read and understood. Well, he did the same thing back in 1953 with the Messier catalog, Charles Messier's own personal copy, and found the marginalia and added in these extra objects that Messier and Messiaen had observed over the course of their lifetimes. Now, over the course of time, people begin to wonder what some of these mistaken objects were. Let me go back and take a look at some of the M40, for example. Now, if you guys know the Messier catalog, M40 is in fact a little double star. Charles Messier's catalog is made up of nebulous objects. Well, Messier, in fact, it turns out, had observed this while hunting for an object in the night sky that someone else had reported. And he landed upon this little double star at the exact location that the other person had noted, said, hey, this might be nebulous. I can't really tell, but it's an interesting little object nonetheless. So he put it in the catalog. And for a long time, people kind of dismissed it as a mistake because they thought, well, there's no nebulous object in that particular region of the sky. Some people thought maybe it might be the location of a comet that had been observed, but that wasn't the case either. So it was eventually decided that at this particular location, if you go right to that location, there's a nice little double star. So it was included in the Messier catalog as a double star. So it's a little interesting anomaly to the catalog of nebulous objects. 47 and 48 were sometime in the mid-20th centuries basically nailed down to their current present-day positions. People figured out that they were 5 degrees off, and they were actually considered to be found as well. This guy right here was another reduction error. This was a discovery of Messiaen, and Messiaen had not taken very good notes, and it turns out that Messiaen had made a mistake in writing down the location of it. This is the galaxy M91. And finally, and we'll get to that in just a second, there's M102, which is a problem. So this is a picture close-up of Messier 40. It's a little double star. So it's cute. So in 1993, by about that time, if you go back, and I have actually a copy here of the Burnham's Celestial Handbook, and I was looking it up just before we started, and I was curious about when M110 entered into the Messier catalog, and I will read for you here. There is a hold on just a second. Oh, I had the wrong one. Well, I had the page open, but then I kicked the book accidentally. Well, it turns out that in the 1978 edition of the Burnham Celestial Handbook, M110 is simply referred to as NGC 205, which is its NGC number. So in 1978, the Burnham Celestial Handbook was not referring to M110 as M110. Sometime in the 80s or early 90s, people just started to think of this little fuzzy thing next to M31 as a separate Messier object. And one of the earliest publications was that included it as such was surprisingly recently. It was there was a book by David Levy called The Sky, A User's Guide, and it referred to this as M110. They just decided to throw that guy in. It was in fact a discovery by Charles Messier, so why not? And so we're getting much, much closer to the contemporary incarnation of the Messier catalog. So here's the problem right here. Says a nebula. This is a entry for M102. Now you'll notice on this side of the chart there is no right ascension and declination. We only have a verbal description of it. It's a nebula between the stars of Boötes, excuse me a second. I will read it here. The nebula between the stars of Omicron of Boötes and Iota of the Dragon. Now, Omicron is a Greek letter, and people would refer to the stars in the night sky by their Greek appellation, and Iota of the Dragon. Now, there's a problem with this. Charles Messier wrote this down in the catalog. There's a problem with this, and he actually gave, in his own personal handwriting, a note of where this was, 1440-56. But let me show you something here. So this is a map of the constellation of Boötes in the night sky, and right there, down in the corner, as you'll see from my copy of Stellarium here, is Omicron Boötes, right there. Now, that is nowhere near Iota Draconis. Let me show you where Iota Draconis is. Iota Draconis is right here. Now, there is another star right here. This is Theta Boötes. Now, this particular object, M102, was observed and taken note of not long before the publication of the final version of Messier's version of the catalog with 103 objects in it. This was actually observed by Messier. And Messier wrote in his little book, I found this between what seemed to be Omicron, Boötes, and Iota. Well, take a look over here. This is a theta right here. I'll zoom in a little bit here. That is a theta. That little guy right there. It is a little circle, like a little O with a line through it. Well, Omicron, if you look, is also a little O, and it doesn't have a little line through it. So what people surmise probably happened is the not quite as fastidious Messier quickly wrote down in his notebook that this was near Theta Boötes, but perhaps he forgot the line, or perhaps he scribbled it out a little too quickly, and instead of writing Theta, he wrote something that, to Charles Messier, who published the catalog, thought was Omicron. So, for a very long time, people were very confused about what object this meant. Well, when it became clear that maybe he had made a mistake, this little hint right here, this 14 hours, 40 minutes in right ascension and 56 minutes declination, turns out that at this approximate location, there is in fact a couple of fairly bright galaxies. The brightest one happens to be a galaxy called, with the other name, called NGC 5866, which actually has been given the name the Fool's Gold Galaxy, because perhaps we're on a fool's errand where maybe we have found a piece of fool's gold in so thinking. But right now, this is what the general consensus is, that the final, with the general consensus of what Messier actually saw. This is probably what he was referring to when he entered that object in the catalog as M102, and what Messier was referring to. For a very long time, a lot of amateurs and people that were publishing this particular catalog, the one that had 109 objects in it, they were referring to it as a duplicate observation of M101, which is not too far away, and roughly on the same declination, roughly on the same declination. But by and large, right now, it's generally considered that this is the prime candidate for that. So for now, we have 102 objects in the Messier catalog. So what have we got? We have a complete Messier catalog, yay, after 270 years approximately. We have a lost object, perhaps found. This is M102, a lovely Hubble Space Telescope shot of it. It's actually quite a beautiful object under dark skies. And we have what seems to be the final version of the Messier catalog. The final reason I think that it is very interesting to amateur astronomers is that it is a glorious exploration of the different types of objects in the night sky. Amongst its numbers are 1 supernova remnant, 4 planetary nebulas, 7 star-forming regions. Those are things like M8 or M42 or M78. 26 open clusters. Those are the loose galactic clusters. Many of them are very poor in stars, but they're included. All different types. 29 globular clusters. It turns out that globular clusters are actually very easy to see in telescopes of Messier's style. 40 galaxies, and some of the most amazing galaxies like M51 or M101 or M33. These are all part of the Messier catalog. And 1 double star. The only thing we're missing are quasars, maybe dark nebula, and a couple of variable stars or something like that. But it's a good collection of objects in the night sky. So let me go through. This is kind of something that I'd like to do. Show you the... And since I'm getting near the end of my talk, if you guys have any questions in the comments, and since there is a delay, I ask that maybe you post your questions now, and by the 20 or 30 seconds that it takes for things to get, yes, a partridge in a pear tree, by the time the questions get posted, I will be able to answer them on the feed. So let's go through the best and the brightest, or the superlatives of the Messier catalog. So the brightest, I will give you a few seconds to guess what that is. And as you probably guessed, oops, I didn't do it in the right order. Sorry about that. I made a mistake in my slides. Let's start off again. The most northern of the Messier objects is M82. So it is at 69 degrees north. Charles Messier's catalog was distinguished because he was observing from Paris, which was 47 degrees north, and he could only see so far. He could only see about 37 degrees below the 37 degrees south. So the most southern object that he could see was 32 degrees south. He could not see any further from his vantage point. So if you wanted to get objects in the southern sky, you would have to go further south. So there's a good chunk of the southern sky that Messier was not able to observe. And he almost observed his entire life from the Hotel de Cluny in Paris. The brightest is, of course, the Pleiades, M45. The dimmest, would anyone care to guess at the dimmest? Okay, I will give you a few seconds. The dimmest is M95 in this lovely picture here by Joe Renzetti next to M96. This is M95 right over here. It is magnitude 9.7. Now anybody who has observed a lot of galaxies knows that 9.7 is not that faint for galaxies. There's a lot more galaxies that are fainter than that. The nearest is again the Pleiades. You would think that it was that double star, M40, but in fact that double star is about 1,000 light years away or so, perhaps a little bit more. And M45, the Pleiades, is in fact just 440 light years away. The furthest is kind of hard to nail down because it's difficult to nail down the distance of the galaxies. The best, I got a lot of different distance measurements. The best estimate of M109 is that it is somewhere on the order of 70 million light years away, but its range is somewhere between 55 and 107, and that is the broadest range that I've seen. So I'm counting this as the farthest Messier object in the catalog, because Messier himself did not include it in his catalog. It was included later on by Owen Gingerich, and this is in Ursa Major. The largest angular size is, of course, the Andromeda Galaxy, which spans 3.2 degrees. That's a little bit more than 6 full moons in width. It is a very, very large object. We, of course, can't see this entire full extent with the naked eye. But if you have a very, very dark sky, you can start to see some of the outer regions of it and get a hint of its full size. It fills many fields of view. The most massive of the Messier catalog is the gigantic galaxy at the heart of the Virgo cluster, M87, which the best estimate I saw is that it has a mass of its stellar mass, not its dark matter mass, of 2.7 trillion solar masses. It is a huge object, much more massive than our own Milky Way. So that is the Messier catalog. This again is the Hotel de Cluny. So I will answer the questions that popped up if you guys have any more questions. Thank you guys for sticking in there. We've still got 27 people, and hopefully there will be more watching in the future. Thank you so much for participating in this experiment. I hope everybody avoids the coronavirus and uses their soap and hand sanitizer. I hope they don't run out of this stuff right here, and I hope their Girl Scout cookies manage to keep them well fed. Jason Hissong asks me, what is my favorite Messier object? That is a really good question because they're all so pretty amazing. I would have to say, and I bet you would agree with me, Jason, that M51, the great whirlpool galaxy, which is on the cover of the Burnham's Celestial Handbook. The Burnham's Celestial Handbook here is one of the most glorious objects in the night sky, and one of the reasons why is because it is a good bright spiral galaxy that really, really looks like a spiral in good telescopes. I saw it a couple weeks ago in the 28-inch down at J-Gap, and it was astonishing. So let me see if there's any more questions. Christine says the Pleiades are her favorite. It's a wonderful object. As a beginner, what 10 would be the best to start photographing? That's a really good question. I think the brighter ones are easier. I think if you have a tracking mount, I use something called an iOptron tracking mount. It's a little thing you can buy for about $300. Sometimes you get used ones a little cheaper on Astromart or on eBay or something like that. You put your camera on it, line it up to the North Star, and stick a good long lens on it, and take a minute-long exposure, and you can get something decent. If you take 50 or 60 images and stack them up, using Photoshop, you can get a much better picture. I think that probably the big and bright objects are the best to photograph. I think M42 is a very easy object to photograph because it's extremely bright. M45, the Pleiades, is extremely easy to photograph. In fact, you probably don't even need a tracking mount for that. You can just take a good 7-second exposure and get a decent image of the stars taken from a long way away. I'd say some of the ones that are the bigger Messier clusters, some of the ones I think M35 actually shows up really, really well, and then ones that are several of them close together. I did a picture of M36, 37, and 38 in Auriga, which are three bright open clusters, and my just ordinary SLR with 135 millimeter lens can fit all three of them in the same field of view. And I took about 20 shots and stacked them up and got a good, decent image of all three of them in the same field of view. So, I mean, if you're a beginner, things like that. So what you want to look for is the bright objects. The galaxies and that kind of thing are pretty hard, except for M31 and maybe the other really big one, which is nearby to our Milky Way, M33, which is in the constellation of Triangulum. So, Greg, that's kind of where I'd get my start. Let me see. Yeah, and Jason mentions that we saw M51 through the Dobsonian. It's really, really great. Which one's the hardest to see? Well, the faintest one, M96, is not that easy. It's kind of faint. I've always thought that M109 was kind of wimpy, and it didn't have a lot of contrast. Didn't show up very well. I always thought that. M76, which is long considered to be one of the harder ones, if you don't have a lot of power and you don't know where you're looking, it's kind of easy to overlook because it's fairly small. M76 is a little planetary nebula near Cassiopeia and Perseus, and Sharon, I think those are ones that are kind of hard to see. I'd have to say like M109 because it doesn't have a lot of contrast with the background. So Joanne mentions he has a Astronomical League Messier certificate. Yes, if you've observed all the Messier objects, you can write into the Astronomical League. You can join them, and they'll give you, you can get a little certificate, and they will tell you that they'll give you a little thing that says that you've observed all of them. Now, it's possible to actually, on certain nights, you can actually do it all in one night. You can do an entire marathon. There are certain ones that are hard to see. Generally, M30 is really tough because it's in the morning twilight, and you're completely out of it by then. Happily, it's kind of bright, and then if the sun is not in a propitious location, M74 and sometimes M77 in Pisces in the evening sky are also pretty difficult in that regard. But you can, if you're a really good observer and the sky is particularly clear, it is possible to actually observe all of them in one night if you're extremely dedicated and you've got a lot of coffee. So, excuse me. And I'm getting lots of comments here. Best in binoculars? Yeah, it's hard to say. I think M31 is amazing in binoculars. Beehive's pretty cool, I agree. Wookie, yeah, Wookie, that makes a lot of sense. Wookie says M74 is pretty difficult. Yeah, M74 is very, very low surface brightness. And also, as I was saying, if you want to do a Messier Marathon, M74 is probably the most difficult object to see because it's going to be lost in the evening twilight. Let's see. Yes, Jason mentions I love using binoculars to visit Messier objects. Almost all of the Messier objects, barring the little tiny ones, can be seen in binoculars. I tried seeing M40 once. It's hard to split. But even M76, if you know where to look, it's a little fuzzy nothing. Very, very tiny. M57 is pretty small, which is the Ring Nebula. That you need fairly high power binoculars, maybe at least 10, if not 15. But if you hold them really steady, it does show up a tiny little disc in binoculars. So I would say most of the Messier objects under really good skies could be seen with a decent pair of binoculars. So I'm going down the list of comments here. What is the largest Messier object, Jason? Largest in terms of its angular size. I went through that before. The largest Messier object is M31 in terms of angular size. It's almost 3.5 or 3.2 degrees across, and the largest one, period, is M87. I mean, it's the most massive. I think some of the other galaxies may actually be a little bit bigger. M87 is very compact, so its reach, its breadth is probably not as great, but if you want to consider large in terms of mass, M87 is the dominant galaxy in the Virgo cluster, so it is probably I guess it wins the prize. I'd say M31 is probably wider if you count all the stars, in terms of its side-to-side distance, but M92 is a beautiful globular. It's also in Hercules. Let's see. Tom, J-Gap, I'm not going to open J-Gap. In general, I can't stop people from going down to the park. If you'd like to go and visit, you're more than welcome, but I'm not going to announce public visits because unfortunately when I do that, usually 50 or 60 people show up and it becomes a non-social distancing situation in and of its own. I mean, in January, I actually opened up the observatory, put a little Facebook note about 2 hours before I went down there, and we had 40, 50 people. So it's very hard to keep people away if I announce that. So I'd like to at least keep the social distancing from happening. Or keep the social distancing happening. So guys, if you have any more questions, I'm going to give this about 30 more seconds here, just in case there are any more last questions. And I'd really like to thank everybody for doing this. I'd like to thank Ness for setting up the Zoom, Ness and Jason for setting up the Zoom meeting. I'd also like to thank Jason in particular for helping me figure out how to record the Zoom meeting, which was a bit tricky, but he's very technically adept, so I appreciate that. And we may be doing this again next month, so stay tuned. This particular meeting will stay on the Facebook page in case for some reason you want to watch it all again. Tell me where I made a mistake and that kind of thing. I invariably probably did, because I do sometimes misspeak. And so since there are no more comments, thank you so much. I am going to end the live feed now.